In this chapter, we're going to start our discussion of cycloalkanes. So these are the cyclic counterparts of the alkanes that we talked about in the previous chapter. So to refresh your memory, if we're dealing with an alkane has the general formula CnH2n plus 2, where we have 2 times the number of carbons plus 2 as the number of hydrogens, and an alkane is saturated, meaning it has as many hydrogen as we can possibly fit per carbon atom. For a cycloalkane, the general formula is just CnH2n. There's no plus 2, which basically means when you go from an alkane to a cycloalkane, what we've done is effectively lost 2 hydrogen from the formula. And anytime we lose 2 hydrogen from a saturated formula, that is one unsaturation. And this is a concept we'll continue to build on when we start to talk about alkenes. Okay, so let's look at propane. So here's propane. If you count up the hydrogens and the carbons, we have C3H8. Now, if we make the cyclic counterpart of this, cyclopropane, what we've had to do in order to make this new bond, because remember in propane, this carbon has 3 hydrogen, this carbon has 3 hydrogen. So if you want to form a bond between these 2 carbons, each of those is going to have 1 fewer hydrogen. So this goes from a CH3 to a CH2 in the cyclic counterpart. So we've lost those 2 hydrogen from the formula, and cyclopropane is C3H6. So what we found is that a ring is an unsaturation. If we had a structure where there's 2 rings, then we would have 2 unsaturations. And again, this is something just to kind of keep in your mind for now. We'll build on this substantially a little bit later in the semester. All right, so we've looked at the 3-carbon ring. You obviously can't have a ring with just 2 carbons. 3 carbons is the smallest ring we can have. From there, you can have larger rings. You can have rings with 4 carbons, 5 carbons, 6 carbons, 7 carbons, and so forth, getting up into very large rings. So these are named just based on the number of carbons. So 4 carbons we know as butane for the acyclic version, and then for the cyclic version we would call this cyclobutane. So we just append the cyclo in front of the name. 5 carbons is cyclopentane. 6 carbons is cyclohexane. 7 carbons, cycloheptane. And so forth. As you get past 7, the rings do become a little bit harder to draw, just because you have to make sure you have each carbon in the ring.